Hello, today's lesson is on similar and congruent figures. And I want to make sure that when we get to the assignment number 42 that we show our work. But before we get to that point, we got to go through the lesson. So in the figure below, lines M and K are parallel, and we want to find the values of Y and Z. Well, this is just what we've been talking about the last week or so, but we noticed that Y and this 81 degrees here are same side interior angles. So all we have to do to find Y is do 180 minus 81, which would make Y a 99 degree angle. So let's write that down. Y would equal 180 minus 81, which equals 99. And now that we know that Y is 99, to find Z, we can just set 4Z minus 1 equal to 99. Then to solve for Z, all we have to do is add 1 to both sides, and we get 4Z equals 100. Then we divide both sides by 4, and we get a Z value of 25. So there's how we solve a problem like that. We've done several. Each one seems to be a little different, but hopefully by now you're starting to get the hang of it. Okay, let's get on to today's content. So we got a couple of definitions to take care of, to mention. First of all, figures that have the same shape and are the same size, their corresponding sides or corresponding angles are all equal. These are called congruent figures. So some of the characteristics are that they are the same size, the sides are the same length, they're the same shape, they have the same angles, and then this little figure, this little equal sign with a little squiggly line above it, is the signal for, or the symbol for congruent. Now, if you notice, these two figures on the left are an example of congruent figures, but the next one, the non-example, shows two triangles, but they are not the same shape. They're different shape, even though they're both triangles. Okay, so if we get into the ALEKS lesson, some of the questions they might ask are, which pairs of figures are congruent? Well, the first two have the same length, same width, and everything, so yes, they would be congruent. The next two, you have a circle and an oval, so those would not be congruent. These are both rectangles, but they're not the same size, so no. If you look at these carefully, you notice you got 1, 2, 3, 4, 1, 2, 3, 4. So each side of the triangle is 4 units long, so that would make the diagonal the same length. So yes, that one would be congruent. So let's check out the next one. Identifying and naming congruent parts of congruent triangles. The triangles below are congruent and their corresponding parts are marked, which means that all of the same sides have the same marks in them, or the same angles have the same marks. So if we look at, for example, angle A, it has 2 lines in it right there to indicate angle A. All we have to do is come over to the other triangle and find out that angle X also has 2 lines. So we're going to put an X in that box. Angle B corresponds to angle Z, and angle C corresponds to angle Y. So we just go through and mark down the labels of those things that are corresponding and congruent. Okay, how about side AB? Well, side AB is this side right here. So the one that's congruent to that would be XZ. Side XZ. Well, side AC is this one right here. So the one that corresponds to that would be XY. And side BC goes from this corner to this corner, so that would be ZY. So we're basically just matching up the corresponding sides with the corresponding letters. And I put the letters in the same orientation or the same direction that they were in the first one. For example, if you notice BC, B has 1 mark, C has 3 marks. So I go to Z and Y, I start with Z and go to Y instead of Y and go to Z. All right, so if triangle BAC is congruent to this other triangle, then how would we label that? Well, we would start with Z, then A, or in this case X, so Z, X, Y is how they would label that. So there's the kind of a congruency statement that shows that all the angles, all the sides, and the triangle in general are congruent. Okay, now the next thing is, what about similar figures? Triangles with the exact same shape but different sizes are called congruent figures, or excuse me, similar figures. So their sides are proportional, but they're not identical. And knowing this, we can actually find missing sides by just understanding what it means to be similar and proportional. So let's get into that. So if you notice these two triangles, they have corresponding sides that are shown in red or blue or green. And if you notice, all of the sides in the left-sided triangle are only half as big as all of the sides in the right triangle. So you notice that there's that relationship there. If you notice in these figures, the angles are all the same, but if you look at them, triangle EFD over here is a bigger triangle. All right, so find the angle measures of a triangle given two angles of a similar figure. If two triangles below are similar, if I know that angle I is 20 and angle G is 110, then what am I going to know? What do I need to know about to find X and Y and Z? Well, first of all, I could start by using the triangle sum theorem to find H, because we're going to need to know that in order to find Z over here. So 110 and 20, if I do 180 minus 110 minus 20, that's going to leave me that angle H is 50 degrees, okay? 50 degrees for angle H. So then that means that angle Y corresponds to angle G, so angle Y is going to be 110. The little teeny angle over here that corresponds to I is X over here, so that's going to be a 20-degree angle. Sorry, my mouse is getting stuck over here. And then Z, which corresponds to angle H, is going to be 50 degrees. So there's those three measurements just based off of a couple of things we've learned before and then what we learned today about similar triangles. Okay, let's try another one. If two triangles below are similar, the measure of angle I is 20, the measure of angle H is 100. So now we got to find angle X, angle Y, and angle Z. Well, we're going to start out by finding G right down here because we're going to need to know that in order to find angle X. So if we do 180, subtract 100, subtract 20, so that's going to be 80 subtract 20, which equals 60. So angle G is going to be a 60-degree angle. The angle that corresponds to that is X, which will make that 60. Then angle Z would be our 100-degree angle. And angle Y would be 20 degrees. So that's how we would do those particular problems. Okay, now what is a ratio? Well, a ratio is just a fraction that shows a relationship between two different fractions or two different numbers. Now in this case, we've got a ratio 2/3 is equal to 4/6. If you take 4/6 and simplify, you get 2/3. Well, what if I have 5/15 and I've simplified it to a point so that I know that the bottom of it is 3? What would I know about the top? Well, I would have to ask myself, what did I divide 15 by to get 3? Well, I had to divide it by 5. And so if I divide the top number by 5 also, I can find out what the top of this number has to be, and that would be 1. So x would have to be 1, so I would end up with a 1/3. All right, use similar figures to find a missing measure. Using the ratio of their sides. So we're going to be looking for this missing measure, which is t. And t corresponds to the number 5 on this triangle. And then we're going to set up a ratio between two other sides over here. So 9 would correspond to, 9 here would correspond to the 3 over here. So now we have our two ratios. Now we have to find t. Now another little trick that maybe you've heard about, but is called cross multiplication. So we do 5 times 9 is 45, and 45 divided by 3 equals 15. So that t that we're looking for here is 15. So those are pretty easy. I kind of like these. So let's try another one. We're looking for a question mark here. And we know that these triangles are similar triangles, which means they are proportional. So I'm looking for a question mark. It corresponds to the side number 2 over here. See how I make a ratio between the corresponding sides? So now I'm going to make a ratio between two other corresponding sides. I could use the bottom ones or the right side ones. I think I'll use the bottom ones in this case. So I'll make a ratio with 20 over 4. Well, all I have to do is cross multiply. 2 times 20 is 40. And then 40 divided by 4 equals 10. So I know that my side over here, the question mark that I'm looking for, is 10. And that's a reasonable answer, because if I have 10 here, if I divide it by 5, I get 2. If I have 20 here, if I divide it by 5, I get 4. So I've got numbers that are still proportional. Okay, let's try another one. We're looking for this question mark. So I'll put down a question mark for what I'm looking for. Make a ratio between it and its corresponding side, which would be 8. Make an equal sign. And then set up a ratio between two other corresponding sides. So I think I'll go with 45 and 9 here. 45 and 9. Now all I have to do is cross multiply and divide. So 8 times 45 divided by 9. So 8 times 45 would be 320 plus 20 more, which would be 340. Is that right? Yeah, so you get 340 divided by 9 is what our question mark is going to equal. Let me make sure. 8 times 40 is 320. Oh, 8 times 5 is 40, not 20. So this is going to be 360. Sorry about that. 360. So when I divide 360 by 9, I get a question mark or an answer for a missing side of 40. And there we go. Okay. Now it says here the triangles are not drawn to scale, meaning that if this is 63 and this is 7, they don't look, this should be a lot bigger compared to this, but they haven't drawn them to scale because there just isn't room to do that. Okay, how about if I have pentagons instead? I can do the same thing. As long as I know that they're similar, I know that they're proportional. So in this case, I'm looking for x. So if I put the letter x, now x corresponds to 6. So I'll make a ratio between x and 6. Now let's look at a couple of other sides. Just pick one. Let's go ahead and pick this one right here, 3.2 on there, and then divided by 2. Well, I happen to notice, if we go back to one of the earlier problems, that 6 is 3 times bigger than 2. So essentially, I've multiplied this by 3 to get this. So if I multiply this by 3, I'm going to get 9.6. So this is another way of showing how to get the answer. X is 9.6. Now I could have done the cross multiply and divide by 2 as well, and I would have gotten the same answer. So here we are back to the end again. Your assignment is number 42, similar and congruent figures. Make sure you show your work on a work paper or in your notebook. Thank you very much.